Hello, good morning or good afternoon or whatever time of the day you are watching this video. Welcome to the next episode of MathMeowTics. Today we're going to talk about the greatest Pythagorean Theorem. And this may be something that some of y'all are familiar with, and it might not be. It may be something that's completely new. But it's an introduction to triangles and how the triangles relate to the world around us, because triangles are everywhere. Now, we can understand that the lengths and sides of right triangles have a special relationship, and we can only use Pythagorean theorem with right triangles. And if you know the lengths of any two sides, you can find the lengths of the third side. And I mean, this is just a preview of the future. We can use Pythagorean theorem also leads us into trigonometry, which then, in that case, we only really need to have one side and an angle, and then that can lead us into finding the missing angles, which is pretty quite wonderful and really neat, and it's what's beautiful about math. Now let's talk about the Pythagorean theorem itself, the concept of it. In any right triangle, the sum of the squares of the lengths of the leg is equal to the square of the lengths of the hypotenuse. So, I mean, the way that we would write this is, so a squared plus b squared. So that's that's that length of that leg squared, plus the length of the other leg, b squared. And then that will give us the length of the hypotenuse, c squared, all right? And then we can take the square root of those, because if it's squared, we learned before recently that if we take the square root of those values, so if I take the square root of a squared, that would give us a, the value for a, which that is really, really neat in itself. So now, let's continue talking. Now we're going to talk about the figure itself. Sometimes it gets a little tricky for us to determine what our legs are and what the hypotenuse is. And the hypotenuse will always be the longest side of a right triangle. So the longest side of a triangle, of any triangle, is across the largest angle in that triangle. And we can order triangles from smallest to largest depending on the size of our angle. Well, the largest angle in a right triangle is going to be the 90 degrees. So I can denote it by putting a little box, or I can just call it 90 degrees. I can then draw an arrow, straight arrow across, and that side of that triangle across from the 90 degrees will be my longest side, in which case will be the C, or the hypotenuse. Now, the converse of the Pythagorean theorem, the converse meaning is that it's the opposite, okay? It's the negation of it. So if a triangle has the side lengths a, b, and c, and a squared plus b squared is equal to c squared, then a triangle is a right triangle with a hypotenuse of the length c. And what we're saying here is that if I didn't know what that angle was, but I did know that the sum of those sides, the two legs, gave us the value of c squared, then I would know and I could say that that value is a right triangle. So it's not too difficult of concept. All right, now again, our formula is going to be a squared plus b squared is equal to c squared. Now, it says in this problem number 1, we want to find the length of a hypotenuse. The tiles at the right, so we're looking, these are tiles that are on anybody's floor. And the tiles, we know that the square, each tile, we can measure it, is 6 inches. And we want to know what the length across, and that length is going to be the longest side. And I know it's the longest side because it's across from my right angle, my 90 degrees. And it wants us to give the answer in simplified radical form and as a decimal rounded to the nearest tenth. Depending on the situation, one or the other might work for you depending on what this is going to give us. But, I mean, quite frankly, different situations, keeping the radical in simplified form will be better than rounding it to a decimal, or vice versa. But in this case, we're going to give both answers. So if this is my hypotenuse is the value that we're looking for. So I know that these two values here, so these 6 inches, these are my legs, okay? And in reality, I label either one as A or B. So I could label this A and I could label that B. Or I could label the other one. I could label this one B and this one A. It really doesn't matter. Either way is acceptable. All right. Now, So this is going to be 6 squared plus 6 squared is going to give us equal to c squared. Well, 6 squared gives us 36, so that's going to be 36 plus 36 is equal to c squared. Now 36 plus 6 is going to give us, let me get out my handy dandy calculator. So 36 plus 36 will give us 72. So 72 is equal to c squared. So now in order for me to solve for the value of c, that means I want 1c. C squared is saying c times c. I don't want to know what c times c is. I want to know what c is. So I need to take the square root of both values. Now again, here's a couple comments that I want to make. So when I take the square root of a value, I have both a plus and a minus. So in reality, my result of 72, the square root of 72, is going to be plus or minus the square root of 72. That's just the rules of taking the square root of a number. But in the case of a value here where we have x or a c, and we're talking about a real life situation, we can't have a negative value. So we're only going to be dealing with the positive values in this situation. But I wanted to make that note so that you understand in the future that when we are looking at both the positive and the negative values possibilities, that you understand that the negative value could be a potential answer, and so therefore either of those positive or negative values would work in terms of our answer. Now the square root of 72, well, let me put that in the calculator, let me check. Okay, so the square root of 72 is not an even number. It gives me 8.485. So I mean, it says and is a decimal rounded to the nearest tenth. So I can say that that's one of my answers. So I'm going to say C is equal to 8 and that's going to be around 8.45. So that's going to be 8.5. But we also want it in terms of a simplified radical form, okay? So now I need to think of the factors, the perfect square factors that will go into 72. So let me talk about those real quick. So 1 times 1. So we have 1 squared, which will give us 1. We have 2 squared, which will give us 4. We have 3 squared, which will give us 9. We have 4 squared, which will give us 16. 5 squared, which will give us 25. 6 squared, which will give us 36. Shoot. Come on. It's being wonky on me here. Sorry about that. Hold on, let me move it over. 6 squared is equal to 36. There we go. I was too close to the edge. All right, now I think I'm going to go ahead and stop there. Let's see. So I'm going to take 72 and I'm going to divide it by 36. No, well, I got lucky right there. Right there off the bat. So I can rewrite 72 as a factor of 2 times 36. And that will give us C. So now I can't take the square root of 2. But I can take the square root of 36. 2 is the simplest as it can go. The square root of 36 is going to give us, if we look over here, the square root of 36 is 6. So I can rewrite this as 6 square root of 2 is equal to C. So these are both of my answers in terms of what the question's asking us for. This one here is in decimal form, and this one here is in simplified radical form. Right, now on to problem number 2. I'm going to do problem number 2 in the next video. I'll probably do the remaining questions in the next video. Because Pythagorean Theorem is a fairly quick and simplified concept. As long as you know the formula and understand how to plug in the values into those, you should be just fine. All right, I'll see you in the next video.